Tuesday, Thursday, you guys will have a quiz and this will be on it, okay? So on your quiz Thursday, you got to be able to work these along with the two kinds of problems we're doing today. So for AL, BR 3, did you find the mass? How many ALs do we have? How many BRs? So times 27 times 35.45. And that one you can round to 0.5 if you want to, but that one needs to stay a half at least. Don't round that one to a whole number.
Wait, how was BR?
Oh, so I was doing chlorine. Thank you.
BR is 80.
80. Thank you. I was doing chlorine. Thank you for not letting me work that whole problem wrong. I'd have been seriously annoyed if you had. So 240 plus 27 is 267. All right, so how do I find the percent aluminum? The mass of aluminum, which is 27, over the mass of the whole compound, which is 267, and then I do what? Times 100. All right. For the percent bromine, I say what? 240, which is the mass of the element, over 267, which is the mass of the compound, times 100. All right, so what'd you get for the percent aluminum? 10 point what, Sophie? 10.11. And what'd you get for percent bromine? Say a little louder. 89.89%. Now, because this question did not have any significant digits, Sophie has 2 significant digits past the decimal, so she's actually got 4 in each of her answers. You don't have to have that many significant digits. You could have rounded this to 10.1. You could have rounded it to 10. Any of those would be correct. You could have in this bottom one made it 89.8%. You could have even made it 90% for all I cared. Okay? Any of those would be fine because I didn't give you any significant digits in the question. Does that make sense? Okay. So, for the last one, how many MNs do we have? How many CRs do we have? And how many O's do I have? 35? All right, the mass of manganese is?
55.
And chromium? And oxygen? What's that, 110? 520? 560?
No, it's 560.
Thank you. What do you get when you add here? Whoops. 1,190. All right, so for the percent manganese, we have what on top? 110 over 1190 times 100. For the percent chromium, we have 520 over 1190 times 100. And for the percent oxygen, we have 560 over 1190 times 100. So what did you get for the percent manganese? 9 point what? 9.24%. And for the percent chromium? What'd you say, Tiffany?
43.6.
And for the percent oxygen? 47 point what?
05.
Everybody got those? All right. Any questions about how to solve percent composition? So we're okay on that. Okay. In that case, let me grab your test papers. I need to send out who? Darlene was one, and there's another. Justice didn't take it. Abraham. I was going to say, I know there's 3. good news is there were no Fs. There were a few Ds, but there were no Fs. There's some years we got a lot of Fs, so I'll take no Fs. I think, in terms of content, the next one I think is easy. However, there's lots of places to make small errors because the content has places for tiny mistakes. Y'all's handwriting is a pain to read.
Who's handwriting?
All of y'all. You ought to be in fourth period with Malachi, Malik, and Mikhail.
Oh, yeah.
Your handwriting is terrible.
I'm writing. I got good.
Lisa.
You can
Huh?
write what I write.
I won't disagree with you on that. All right, if you look at the points, everything is 2 points except the very back page. The very back page is 4. The answer sheet on the back works the same way. Anything circled is a total, okay? I grade them 1 page at a time. So everything is circled is a total, okay? So if you see something circled, it does not go to that question. It is a total for the page. Yes, ma'am.
I gotta check X.
You got to check X. That means it's an X. Do you have a question about the check X or why it's wrong and when to answer it?
Yeah.
Which question?
29.
One is 29, sorry.
NI2, parentheses, CRO.
All right, so NI is nickel and CrO4 is chromates. Okay, does nickel need a Roman numeral?
Yeah.
Yes. So what Roman numeral should it have based on the number at the end of the formula?
3.
Nickel 3 chromate. What did you write? That's why. I guess you read the wrong line maybe off your oxidation sheet. It happened multiple times, so I'm just this one right below it. So several people wrote oxalate. This is the one right below it.
Why wouldn't it be?
Because it's oxalate is C2O4,
Oh.
and that's CrO4. All right, who else has a question? Now, that back page that has the, what will be called stoichiometry, and the front page where it has grams, moles, atoms, you will see that again. Not on the next test, but the one I said would be the next test, 2 tests from now. On stoichiometry, you'll see that again. Okay? That's not going anywhere for a little bit. Hey, Mr. Rector. What's up? Well, here do I have what?
Luke.
Luke, third.
I need to see him for like 30 seconds. If you remember.
Okay.
Maybe between one of us will.
Okay. All right. You're welcome. Yes, that I remembered. I assumed. I assumed. And articulation 101. And articulation 101. Yes, I got that. Okay. I'm good on all that. All right. I just assumed those things.
This is the big stacks that I give you.
Uh-huh.
That actually go to.
Right.
I need to take to
They're
it.
not backups.
Okay. That's helpful when you tell me that ahead of time. All right. What else? What? Okay. 10-4 sulfide. All right. So SN 4. Sulfide has a 2. So you brought the 2 and the 4 down, right?
Yeah.
So you had SN2S4. So this is like math class. Okay? If you have a 2 over a 4, Tiffany, in math class, what do you do to it?
Simplify.
That's all. That's why you got a -1. You just didn't simplify. This is the only thing that got partial credit in the formulas. Okay? So you needed to take this and make this SN, make that a 1, and make that a 2. So you should have lost 1 point. Is that what I did? That's why. There were 3 of them that had to be reduced on the test.
On 35.
As long as you tell me what it says.
It's iron 3.
Iron is Fe. It has a 3. All right. OH has a 1. All right. You have to have parentheses because it's what? Why does it got to have parentheses? It's a polyatomic ion. Came off the polyatomic ion side. The 3 comes over here. The 1 comes over here. The parentheses have to stay because the number outside is a what? It's a 3. You can take them off if the number outside is a what? It's a 1. But it's not a 1, so they have to stay. All right. What else? 43. Tell me what it is.
How many moles of iron and then the Roman numeral 3?
Cyanide.
Yeah.
Tell me the mass.
128.9.
128.9. All right. We're going grams to moles. We know moles gets a 1, right? Now, it said iron 3 cyanide, and you have to write the formula. So the same thing that Samaria just asked is what you have to do first. So you have to write the formula. Iron has a 3. Cyanide is a polyatomic ion. It has a -1. So you're going to bring your 1 down and your 3 down. And the formula you get is this. Now you can find the mass. You forgot the parentheses, didn't you?
I'm getting crossing.
Ah, so you had what, 3 irons?
Yes.
Okay. So when you did that, you'd have 1 iron, you'd have 3 carbons, and you'd have 3 nitrogens. So you'd have 55 roughly, 12, 14, it's going to be 42, 36, 55. What's that? 8 and 5, 3, carry my 1, 6, 9, 133. So, anybody else?
Number 25, CuCl, is that copper chloride?
Copper 1 chloride. Okay, so you write copper and you write chloride. Okay, but this needs a Roman number because when you look up copper, there's more than 1 number listed on the sheet, right? So what number came from copper in this formula? What came from copper right there? So you got to put the Roman number in because there's more than 1 number listed on the sheet. Tomas.
Number 5 says N66.
Okay, the atomic number for zinc up there is 30. So neutrons we find by doing what? 66 minus 30 should be 36. Unless I put the wrong number in my phone with the touching the numbers. Okay. Well, it's entirely possible because I touched the letters A, B, C, D with my finger on the phone. So it's entirely possible I got the wrong answer. Punched in.
I don't know how you can say 396.
What else? Anything else on the test that's bothering you?
Number 24, MgCO3.
Okay. MgCO3. Mg is what element? Magnesium. CO3 is carbonate. When you look it up on the oxidation sheet, does it need a Roman number? Look it up again.
Okay, I know.
Yeah, it doesn't need one. What else? Anybody else?
Okay, so number 40, phosphorus tetrachloride. Would you leave the 5 with the chloride, or would you put it at the phosphorus?
You would leave it with a chloride because it's old system. You would just say P has no subscript because there's no prefix on it. And then the Cl gets a 5. P and then Cl with subscript 5 because the prefix is on the Cl.
Okay.
What else? Now, for the purposes of the next unit, we're going to do starting late tomorrow and all day Thursday. If you had trouble with questions 31 to 41, those 10, if you are struggling with those writing the formulas, you need to get help from somebody ASAP. I'm going to be a tad busy in the afternoons, but there are plenty of people I can direct you to who can help you. Okay? They can either work on their Honor Society hours they're going to want for next year, or they're currently in the Honor Society and need to earn hours for tutorial. Okay? But you need help if you can't do those ASAP before Friday. Okay? There are not many of you who are struggling in that area, but there are a few. Are there questions before I take those tests back? All right, if you will, let me have those tests back so that Abraham and Darlene can join us. Now, the next two tests, other than the benchmark, are entirely for response. All right, there's no multiple choice to be found on. All right, if you will, let Abraham and Darlene in. You need a periodic table today. I think that's it. Calculator if you don't have one. You should all have one of those.
Nothing to you, dang, leave me alone.
Alright, let's turn that back up there. Let's get rid of this.
Sorry. I ain't nothing to you. I ain't nothing to you. I wasn't talking to you.
Okay.
I think they're secretly interested in each other.
I ain't nothing.
I don't care.
No, but.
Oh, okay. I didn't even like that. That's why you got that notebook.
Yeah.
Yeah, I need them more.
What notebook she got?
Okay, I'm ready to do.
Well,
I ain't writing mine down.
All right, let's talk about the empirical formula. Now, the two math problems we're going to learn how to do today. You're going to do a sort of worksheet lab tomorrow with it. Now, the worksheet lab you're going to do tomorrow, you cannot use your notes on. Okay, did y'all hear me say that? You're going to get a partner, and a partner only. Now, okay, you may not have your notes. So if you don't practice tonight, you don't know anything, some poor person in this room is going to be stuck with some lame person who doesn't know how to work these questions.
You gonna pick it up, honey?
Typically, I do not. I let y'all pick so that you can choose people of your own choosing. Now, if we're an odd person, typically Baden chooses to work by himself, so the rest of you will be in an even number of pairs. If we're an even number, Baden, you're going to have to suck it up and be a partner tomorrow, okay? Yes, Tomas.
Are we gonna get homework for this?
Yes, we are.
Okay, thank you.
Okay? Now, what is an empirical formula? First of all, it's often referred to as the simplest formula. It is a formula that is in lowest terms, meaning it cannot be reduced. So if we have something like CaBr2, how many CAs are there? 1. How many BRs are there? They are in lowest terms. It is an empirical formula. Now, do we always have formulas that are in lowest terms? Of course not. Sometimes the formulas have larger numbers. So let's say that we have one like one that you might have seen on the test, like C2O4. If you have something like this, what would you need to do to it? You would what? You would reduce it. And you would reduce it into what? So this is the empirical formula. This is what we call the molecular formula. And we're going to talk about it after a while. Okay? Now, sometimes we have something like this, which confuses people. Is that empirical or molecular? This is why I said it confuses people. I have one person yell empirical and one yell molecular.
It's not a binary.
It's not binary.
And it doesn't have parentheses, which means it's a one.
It means it's what? Okay, it is a 1 on the outside. That is true. Can it be reduced? Is basically what I'm asking.
No.
Why not?
Because you can't change the form.
All right. I could change the 4, possibly.
But the 4 is like the sulfur. Wow.
Okay, it's about the sulfur. What number's on the sulfur? That's the piece I needed you to tell me. Okay? The subscript on the sulfur is a 1. Okay? You could reduce if all the numbers are reducible. But because sulfur is a 1, all the numbers can't be reduced. Okay? So, if you had something like this, all right, so that's not able to reduce, so it's empirical. But let's say that I have Na2C2O4. Can that be reduced? That could be reduced, okay? We don't reduce it because it's an ionic compound, but it could be reduced, okay? Now, this, and this could be reduced. Everybody okay with that? Okay. Now, I'm not going to leave that one up there, though, because we typically don't reduce that compound. I picked things that I know you'd see. All right. Whoops. Raise that up. All right. So, we're going to calculate formulas mathematically today. We've been writing formulas with oxidation numbers for about a week now, maybe a little more. And today we're going to do it mathematically. Okay? So, these are the steps to find an empirical formula. And believe it or not, this is one of the things when we get to June that people remember the best. The second one we're going to learn today is the one that we always forget. But this one, for some odd reason, we always remember. So, what's the first thing we've got to do? Well, if we're given percents, we have to change percent to grams. Sometimes we'll be given percent, sometimes we won't. So, we may have to do step 1, or we may not. If they give it percent, we change it to grams. If they've already given us grams, we just skip step 1. Okay? Step 2, everybody knows how to do, because I don't think there was a soul who did this wrong on the test. We've got to change our grams to moles. All right? We've got to change our grams to moles. Now, step 3 is a little wordy, but it makes complete sense once we work it, because it's just like something you do in math class. We're going to divide the smallest number of moles by itself. Okay? Now, if we divide the smallest number of moles by itself, then we have to divide all the other numbers of moles by that smallest number. So in math class, if you divide by 3 on the left, what do you have to do on the right? Divide by 3. You got to do it to both sides, right? So in this, what I'm saying is if you divide by that smallest number, you have to divide all the numbers of moles by that smallest number. You can't just do it in one place. You got to do it in all the places. And then the last step is the easy one. Write the formula. Okay, convert percent to grams, convert grams to moles, divide by the smallest number, and then write the formula. Everybody got it? Did I hear a no out there? You good? All right. So here's our sample problem. We're going to do 3 of them because I've altered something in all 3 of them so that they have something different that could trip you up. You got it written? Anybody still writing? Let me ask you.
Yeah.
Okay. Let me rephrase my question because Samaria writes faster than the rest of y'all. So if she answers yes for y'all and the rest of y'all still writing. All right, how about now? Still writing? For the love of God. Are you working it or writing it?
I was ready to vote. So
Oh. All right, so step 1. We got to change the percent to grams. So we have 32.38% sodium, 22.65% sulfur, and 44.99% oxygen. All right, so what do you think we should do to change percent to grams? What should we do? Easier.
When you do it,
Okay, so what do we do out of 100?
divide.
Easier. Nope.
Hey.
Nope. No.
Yes.
What'd you say?
Me,
Yeah.
with the decimal place?
Nope.
Oh, no, then, Miss Wall. You said all of it.
Hey, what's easier today?
Percent.
I would just
take
take
percent.
Because who was it? Was it Samaria that said, assume it's 100 grams, right? 100%. So if it's 100%, it's 100 grams. So we're just going to get rid of the percent and write.
You already read.
Yep. Okay. She said it was 100%. It's now 100 grams. So we don't have to multiply. We don't have to divide. We don't have to do anything except make them grams. All right. Step 2, I know you know how to do. So what are we going to do to make them moles? Going to draw a chart. Okay. What goes on the bottom? Okay. So grams are down on the bottom. What goes on the top? Okay. What goes beside moles? All right. Now, what do I put beside all those grams? The atomic mass. So sodium's 22.9, sulfur's 32.0, and oxygen is 16.
Do we do significant digits on it?
You don't have to. I would recommend taking it out a couple places, only because you don't want to round too close to the decimal, because I have a couple that if you round too much, you wind up with the wrong answer. All right. Anybody lost by step 2? So we converted them all to moles. Everybody okay with step 2? All right, so step 3 is to do what? Divide by the smallest number. So which one is the smallest number out of those 3? 0.7. Okay, so we're going to divide by 0.7078, and we get what? 1. Now, we divided the smallest number by itself. That's the first part of step 3. Now we have to divide all the other numbers by what? That smallest number. Because just like in math class, if you divide by the left side by 3, you got to divide the right side by 3, right? So we got to divide here by that same number, by 0.7078, and divide here by 0.7078. And we got to see what we get. Okay? Okay. Now, what is 1.99 the same as? It's the same as 2. What's 3.97 the same as?
4.
It's the same as 4. Now, the last step is to do what? Write the formula. All right, so this 2 came from what? Came from sodium. So Na has a 2. The 1 came from sulfur. So S has a 1, which you don't have to write. The 4 came from, so O has a 4. And there's your formula. Questions? Now, when you finish writing it, should you have to reduce this formula? No, because the point of this is to find the empirical formula, which is the what? Simplest formula. Everybody with me? Okay.
This is what we're doing.
That and the molecular formula that we're going to learn how to do.
Will we ever have to write
The name? That's part of the lab tomorrow, yes. After you calculate it, you're going to have to name it tomorrow. Okay? All All right, everybody got it? All right, write this one down too. This one's got an oddity to it that you're going to see regularly. All right, we're there? All right, so tell me what to do.
You're gonna write the numbers down.
Okay, with what unit on the end? So 26.56 grams of K, 35.41 grams of CR, and 38.03 grams of O. All right, from there, I'm going to do what to them? All right, convert them to moles. What goes on the bottom?
Grams.
Okay, on top, it goes beside moles. 39.10, 51.9, 16. And again, I think it was Samari who asked me, how far do you need to take it out? Just take it out at least 3 decimal places. And I'll wait on you to catch up. All right, all I did was calculate moles, and I'm waiting on you. All right, so what do I do from this point? All right, so who's the smallest? The first one, all right? So 0.679. So I'm dividing and I get 1. So what do I do with that number? Okay, so I want you all to punch this in and see what you get. Particularly that bottom number, because that's where the catch is. Okay, everybody can see that this one comes out at 1.00 something, something, something. And you can tell that's 1 pretty easily, right? It says bottom number, then things get a little hinky. Okay, so 2.376 divided by 0.679. All right, has everybody had a chance to punch it in their calculator and get a number?
Yeah.
Okay, so I got 3.499. All right, now what do we do with that number? To what?
Okay.
4.
So
All right, a lot of people want to round it 4. Some people want to round it down to 3. You can't do either of those things. Okay? This number is what? What's 3.49? That's 3.5. Okay? So when we write this formula, we have a K with a what? A K with a 1, a CR with a, and an O with a. Now, did we write any formulas last week that had a half in them? Not starting today. So, think math class. How have you learned for years to get rid of a half? And don't any of you tell me you haven't, because you have. Okay? How have you learned to get rid of a half in something you don't want a half in?
I feel like I ain't in math class.
I know it in a minute. So, how do you get rid of a half if you don't want a half?
You got it.
You got this half and you want it gone.
Add another half to it.
No,
You got to multiply by something. By what? I heard it. Multiply by 2, or the reciprocal. Okay, that's the right word, reciprocal. So, what's the reciprocal of a half? You multiply by 2. Okay, so 2 times 1 is what? So you get K2. 2 times 1 is? So CR2. Now you might need a calculator for some of you for this one. 2 times 3.5 is? 7. And there's your formula. Okay? Questions? Okay. Now, I'm going to help you set up the next one, and then you're going to work it. Because I put a glitch in the setup. Nope. There is not. All right, now let you write that one down. Because I jacked up the setup on this one. So I'm going to help you set it up, and then you're going to work it. All right, you got it?
Yeah.
All right. Who said that?
Me. I'm writing slow, dude.
Well, you need to pick up the pace today. Why's your hand hurt?
All this work.
All this work. You have got to be kidding me. All right, so while Jade is catching up, tell me what's different about this question the way I set it up.
you got grams in it, 6%.
Okay, I've got grams instead of percents, that's one thing. What else is different? Okay, I got yielding. I got what? I got a total. I didn't give you an individual mass for something. Okay? So what you're going to have to do?
Work backwards.
Sorta. What did I give you the mass of? I gave you the mass of oxygen. So what's the mass of oxygen? All right. I gave you that, but did I give you the grams of P?
No, subtract it from 10.
There you go. Okay. I didn't give you the grams of P. You've got to get the grams of P. Okay. This says that this is the compound together, right? You need the grams of P to be able to put in here. Whoops. That's not what I meant to do. Okay. So you've got to use this and this to figure it out. So if you listen to, I think it was Samaria's voice I heard, she said take the 10.150 which is grams of P and O, and take the 5.717, which is grams of just O, and do what with it? Subtract them. And you'll get grams of just P. Did somebody already do that for me? What was it?
4.433.
4.433. All right, so that will go there. Okay? Now, you solve and get my empirical formula. Everybody got it? Need a little longer? Where are we at?
Done.
Okay, I'm done.
All right, what'd you get?
P207.
All right, let's work. Those are not all the same answers.
Oh, yeah, that's right.
All right, let's do it. All right, so you had grams, moles, grams. We had ones. What do we have here?
30.97.
Okay, if you rounded to 31, it won't make any difference in your answer at all. Okay, will not change your answer, so don't worry about that. I have not forgotten. I just need to look up the prices and the numbers for meter sticks, baking soda, magnesium, and do I need anything, or can I just write down 4 cases of paper? The book is on my desk. Well, it was in your email. I just hadn't remembered it. I thought you said the 20th. Today is the 20th. I'd have swore that email said the 20th. But Thursday would be better.
Thursday's fine.
Okay, thank God, because I just pulled all that crap out at the end of the first period. I was like, oh my God, I got to get it done.
You know the main reason.
Well, yeah.
I know where that's coming.
Okay.
Yeah, no, we don't meet till next month.
Okay. Well, I'll have it to you by then.
Yeah, that's fine, that's fine. I'll remind you. I'll give you a gentle reminder.
Thank you. Trying to get it done for you. All right, so we have those numbers.
Yeah.
Okay, and you divide it by the smallest.
Yeah.
Okay, so 0.1431 equals 1. 0.1431 equals, what'd you get here? 2.5? Yes?
Yeah.
Okay. And so we said P102.5 multiplied by 2, and you got P205? Yes? Okay. Anybody not okay with how we did all that? Yes? No? I'm on time. All right, let's do one more. Let's do... Can't remember which one I want in this one. Do 2. Just do 2. You don't even have to write it down. Just try it real quick. Make sure we're all on the same page. Just do number 2. And then we're going to do molecular. I'm just going to do one more. We're not going to short us on molecular. I got 3 things over there.
Did you read it how I spelled it? No, read why did you ever mention to the conversation? I don't know.
I'm just keep adding you bed.
We'll see.
Actually, I really don't care.
Okay.
Right.
Okay, that's fine. Don't talk to me. You just said y'all.
No, that's fine.
Oh.
All right, what'd you get?
FE203.
All right, I got some nodding. Anybody not get FE203? Mr. Dr. Phillips don't count. Anybody not get it and need me to work it?
I was just speaking for your side.
Okay. Anybody want me to work the question?
I'm not silent, but I.
Anybody need me to work it?
No.
All right. Now let's talk molecular formula. All right. So, molecular formulas. All right. Show the actual number of atoms. Now, this one's a little odd. Okay. This one may or may not be reduced. For example, if you have one like S2O4, what do we know that we can do with S2O4? I heard somebody mumble something. It can be reduced, right? So we would change S2O4 into what? SO2. Okay, so we know that S2O4 would be the what formula? This will be the molecular formula. And this will be the what? This will be the empirical formula. But what about one like we just had a little bit ago? What about Na2SO4? Can that be reduced? No. Okay. This is already in lowest terms. So it is both the empirical and the molecular formula. Okay? Because it can't be reduced anymore, and it's already in lowest terms. It is both the empirical and the molecular formula. Okay? It can't be reduced anymore. Does that make sense? All right, have I given everybody enough time to write down what they need?
Yes.
All right. So, how are we going to find these? Well, we need two pieces of information. Number one, we have to have the molar mass. Okay? If they don't give us that, you're not finding the molecular formula ever. Okay? If it's not given, you're not finding it. The second thing you have to have is you have to have the empirical formula. Or the info to calculate this formula. Okay? One or the other. today, we're going to start with being given that formula. And then by the time we leave today, we're going to calculate both questions in one. Okay? Because your lab tomorrow is going to require you to calculate the empirical formula first, and then you're going to calculate the molecular formula. Everybody with me on that?
Yeah.
Okay. So, how are we going to do this? You're going to take the mass that's given, which is essentially the molar mass. You're going to divide it by the mass you add up, which is the empirical formula's mass. Now, when you divide these two masses, you will get a whole number. If you don't get a whole number at this step, you did it wrong. You have to get 1, 2, 3, 4, 5, 6, 7, 8, something of that nature. Okay? Because this is the number that your formula was reduced by. It's not reduced by a fraction. It's reduced by a whole number. You take this whole number and you multiply it through the empirical formula, and you get the molecular formula. We're essentially looking for the number the formula was reduced by. Okay? The empirical formula was reduced by something. We're looking for that number. If it was reduced by 2, which is the most common number it was reduced by, then we multiply it by 2 to get back to what it used to be. If they're one and the same, what would it have been reduced by? If the empirical formula and the molecular formula are the same, what would it have been reduced by? A 1. Okay, and that will happen. And you'll multiply it by 1 and you'll get the same answer. Does everybody have it?
Yes.
Everybody have the steps? Gage, you got them? Took some speed pills on that slide. All right. There's our sample.
Funny.
That was funny.
No, it wasn't.
All right, you got it ready?
Oh, yeah.
Now? All right, what's the mass that's given? Okay, the first step is to take the mass that's given, divide it by what you add up. Okay, so what's the mass that's given? Okay, so 283.889. Divide it by what we add up. Okay, what is the only thing left that we can add up. So that's what we're going to add up. So how do we add up P2O5? Okay. So how many P's do I have?
2.
How many O's do I have? All right. I'm going to use whole numbers. It's easier on my math. 31, 16, that'll be 62, 80, 2, 14, 142. Okay? So that's the mass that we add up. That's his molar mass. Okay? So where am I going to put it? Under the bottom, because that's what I added up. Okay? Now, when I divide this, this should be a whole number. This is the number this formula was originally reduced by. So what do I get when I divide? Somebody divide that for me. What I get? Yeah, no, what'd you get on the calculator though? Okay, so 1.999 is the same as 2. Okay, so even though it didn't turn out to be exactly 2, you saw that it was 1.999, which is the same as 2, right? All right, this is the number the formula was reduced by. That's what that number means. That's what it's telling you. Okay, is everybody with me on that? Yeah. Okay, so that's what this last step is for. You're taking the number it was reduced by, which is a what? A 2. Okay, so you're taking this 2 and you're multiplying it through the formula, which is P2O5, to get back to what it used to be. So what did it used to be? P4O10 is what it used to be. Now, here's the stupid mistake people make all the time. They get this answer and they go, dang, that formula needs to be reduced. And then they reduce it. What was the point of this question?
To get it back from the non-reduced.
Exactly. So don't look at it and then reduce it and wipe out all the work you just did. Okay? This formula is not supposed to be reduced because that was the point of the question. Okay? You'd be surprised how many people do that on a quiz or a test and wipe out their work. Okay? If you do that, I'm going to take half your points. So if it's like a 20-point question on Thursday, I'm taking 10. Don't do that. All right, you do that one. Oh, wow. You do that. Yes, let's. Because then we're going to combine the two, like the lab tomorrow. Because tomorrow, after you calculate them, as Sophie's already figured out, then you have to name them. Because we're going to tie it into what we've already learned to do. She asked me that one more time. You are not slow reading. Read one of the earlier texts. Got an answer? Yes. All right, here on this. Let's wait a minute.
Bye. Hey, now, look, now.
Y'all be nice out there. That'd be hard to do all in. I can go home and listen to my own children argue. Yeah. Huh? Sure. All right. We got it?
Yeah.
What'd you come up with?
C6H6.
Anybody else?
Oh, I've done it right.
Very good. So we got 78.110 divided by 13, and we got 6. And we said 6 times CH, and we got C6H6. Anybody not get that? Yes, no? Darlene, did you get that? Okay, you're just looking at me like, what's that woman talking about? Maybe you just don't like me. It's all good. Anybody?
Nope.
So everybody can do empirical and molecular formulas tomorrow in his lab. Nobody's going to be like, can't believe they stuck me with this person. Okay. Now, this is what you're going to see on the lab tomorrow. So write it down. So you got something to look at tonight. I don't want anybody stuck with somebody going, dang, they stuck with some lame butthead. I'm going to flunk this lab tomorrow. How many people I have absent? I know I don't have Justice or Marissa.
Where is Marissa? Wow.
Nothing.
Y'all look kind of cold. All right, we got it written?
Yes.
All right, so if you get this tomorrow, which you're going to see 5 of, okay? They're all 20 points each, and there's even a bonus question. All right, what you going to do first tomorrow when you see this question?
Change your minutes to your
All right, so the first thing you have to do is find the what first, which would be the what formula first? The empirical formula, because it's not given, right? In this last 2 questions, you had the empirical formula given to you, right? And this time the empirical formula is not given, so you have to find it. So you've got to change the percent to grams. So 85.64 grams of carbon and 14.36 grams of hydrogen. All right, and we're doing what with it once we have it changed to grams? Converting it to moles, okay? So grams, moles. 1 next to moles, 12, 1. We get 14.36 moles. And let me use the calculator on that one rather than guess. I think I know, but yeah, that'd have been in the ballpark. All right, so what do I do from there?
Divided by the smallest.
All right, what's the smallest number?
7.
All right, so dividing by 7.136 gives me a 1. divided by 7.136 there gives me a what? Okay. So what do I end up with?
C1H2.
Now, that is the empirical formula. Everybody a chance to catch up, and then I'll ask you the next question. Anybody having difficulty with the first part? Okay, so what would we do from there?
You would have
Find
to
the
find the
formula
masses.
Okay, we need to do the molecular formula. We need two masses, right? How many are given to us?
One.
One. Okay, so which one is given to us?
The 48 forming.
Okay, so the 42.08 is given to us, and we have to find the one we need for the bottom, right? So what do we add up to find the one for the bottom? The CH2, right? So how many C's do I have? And how many H's? So times 12 times 1, you get 12, you get 2 for a total of 14. All right, so where's that 14 going to go? Underneath. So 42 divided by 42.08 divided by 14 is what?
3.
All right, so that 3 means the formula was what? Reduced by 3. So what do I do with that 3? Multiply it through by C1H2. So what do I get? Yes, exactly. Okay? Everybody got it?
So we have to plug the number that we got for the imperial form into that one.
I'm not sure I understand the
Regular,
question.
like- okay, never mind. I understand.
Okay. I just didn't want to answer it wrong, which is why I wanted clarification. Anybody else? Question? All right. I want you. Never mind. No, I don't. Find your homework sheet from. I know some of you are going to say, I don't know what that sheet is.
I lost it.
Better locate it.
I lost it.
I ain't got any spares. It's the one that looks like a photocopied textbook that I gave you several days ago.
I wasn't here.
Yeah, you were. Looks like. It looked like this, only it said problems on one side and application problems on the other. And I've given every copy I have away.
Does it count as?
It's blank on one side.
No, it says problems on one side, problems on the other, and it's blank on the back side.
Yeah.
Here, one of our subjects. I'll be down away on the top version. Looks like this. Okay, that's nothing on the back. Oh. There it is. Abraham's found his. All right. We're going to do, one of our subjects right. We're going to do question numbers 10C, 14, 15, 16, 18, B and C, and 19. Okay? And I'm even going to give you 10 minutes to work on your homework today. Now, is there anybody who cannot find their homework? Cannot find their sheet? Is there anyone who's not written on their sheet?
Well,
Well, I just
like
read
this
the
way.
question on there.
I got what Ashley's supposed to do.
I don't care. Can I borrow it for a second? Because I'm sure there's gonna be somebody in third period who cannot find that sheet. We're gonna make a couple copies real quick. I'll be right back with it. Before I'm trying to scramble and find the original.
I take that back later. I'll just point out, like,
9 minutes.
Is this on the problem side?
Yes, it's on the problem side.
Or the
Thank you, Peter.
Let me get that one.
You get what? New copy?
Yeah. Nah, I'm good.
Susan,
Oh.